In today's video, I'll share my progress and struggles making HuggingFace SO-ARM101 work with one of the best value SBCs on the market right now, Arduino Uno Q. It went better than I expected. I got both leRobot and ROS 2 Jazzy running locally on the board with Teleoperation, inverse kinematics, and manipulation all working directly on Qualcomm chip. It definitely wasn't painless though. Keep watching if you want to see how well Arduino Uno Q handles modern robotics stack. Don't really want to start with a long time ago in a galaxy far away, but just in case you're completely new to this, SO-ARM101 stands for Standard Open ARM 101 and was originally designed by Robot Studio in collaboration with HuggingFace. You can buy the parts and 3D print the rest yourself, or buy the kit from a number of different distributors. I got mine from Seed Studio last year while visiting their Shenzhen office. And then there is Arduino Uno Q. The claim about best value SBC doesn't come from me, it's from Jeff Gerling's video "This is no joke, SBC hobby is dying", published, fittingly, on 1st of April 2026. In short, the demand for AI cloud compute has inflated RAM prices, therefore budget SBCs suddenly becoming not so budget. I know this channel is called Hardware.ai, so there is that AI in the name, but listen kiddos, I started this channel in 2019 when AI meant something different. Well, kind of. So I'm just as pissed as everyone else about data centers gobbling all the RAM for ChatGPT 6.9. Back to Uno Q. It has both MPU and MCU components, namely Qualcomm Dragonwing QRB2210 and ST-STM32US8S. I've got option with 4GB of RAM and 32GB of eMMC. Since the board lacks expandable storage, I strongly recommend the 4GB version, which is being sold for $55. Given that a comparable Raspberry Pi 4GB goes for $120, this indeed looks like a great value. The A53 core is a bit older than Pi 4's A72, but the clock is higher on QRB2210, going up to 2 GHz. It sounded like the board that has real potential for robotics, so I grabbed one and paired it with HuggingFace Robot Arm to see how far I will get in making the work together. Spoiler, pretty far and still going. Getting started with Uno Q, or Uno Q as Italians call it for some reason, was a cakewalk. By default, the board is pre-flashed with Debian 13, which is okay. There are also already Armbian images. It was really tempting for me to go down that rabbit hole, but I resisted the temptation and simply went the tutorial way. Install AppLab, connect the board, configure it, and voila! You can access the shell either directly using ADB, or if your computer is on the same Wi-Fi network as the board, using SSH. SSH is my preferred way, using VS Code SSH extension. You basically have the convenient access to board's terminals, file system, and can run coding agents from your computer. With SSH access working, the first thing I tried was Teleoperation with leRobot HuggingFace framework. Create virtual environment, git clone the repository, and install leRobot from that repository with pip-e.feedtech. Feedtech part is for installing the servo control package. Annoyingly, it also pulls things like PyTorch. Exactly, PyTorch 2.10 has a regression that makes it crash on Arduino Uno Q and potentially some other older ARM A core boards. The workaround for now is to upgrade to PyTorch 2.11, where it's fixed. You will need to run calibration before Teleoperation to make sure leader ARM starting angles match follower ARM starting angles. The Teleoperation works very smoothly without any issues at all, and I expect the data collection will work just as well. I kind of skipped over the whole process of building SO-ARM101, since if I do start talking about that, I might as well make a full feature-length movie. I only have two pieces of advice to give here. First, if something feels wrong when building, it's probably because it is wrong. Most of the time when I could not put the parts in place, it was because it wasn't meant to go there. Second, the Seed Studio version overall is a good quality with detailed build instructions. There are two minor annoyances though. The first one is that the screws and the spacers to attach the servo board to the ARM are wrong size, so it doesn't actually stay in place. And the second annoyance are the clamps, which are basically due to some design flaw are disposable and break almost immediately. You will either need to 3D print your own clamps or buy them online. Continuing with Uno Q. The next thing to try was installing ROS 2. There's not so much information available, but from what I found, the relatively pain-free way to have ROS 2 Jazzy running on Uno Q is to run it in a Docker container. Docker is installed already on the official Debian image. That is a good news. The bad news is that the Docker file system is mounted here, and for some reason, by default, there is only 8 GB available for the whole root mount. To circumvent this, I moved Docker files to home username, which has around 16 GB available. I have an efficient Docker container workflow, which goes like this. Start with the base container, run it. If you prefer, use dev containers extension in VS Code or simply the terminal. Figure out which packages are necessary and which commands do you need to run in what sequence. Then open bash history of that Docker container and translate it in a Docker file. Use AI if needed. You can iterate much faster this way than simply trying to build the Docker file over and over again. To make it faster, I did it on my powerful PC, and then I simply transferred the Docker file and Docker Compose to Uno Q. They are in a GitHub repository for this video. You will need to run one of these containers on Uno Q and exactly the same container on PC. The one on PC is for executing our RVS2, the ROS visualization tool. There we can control SO-ARM101 3D model, plan and execute the movements. The package I found for ROS 2 Move It is in 80/20 state. A lot works out of the box, but for example, the gripper is in the wrong position. And following the advice to calibrate, the robot doesn't work either. So what's next? What about really cool stuff like visual language action models? Basically, that's the tech that allows the robot to look at the scene and understand the command like pick the red block and put it somewhere else, without me coding exact coordinates and the logic. Or maybe reinforcement learning with policies like HIL-SERL. I've already done some research, and despite it looks like some cutting-edge engineering, I believe that should be possible. And if the Uno Q cannot handle it, well, then I'll just have to find a more powerful board from Arduino to handle the task. Subscribe to see if I can actually make it work.